So, as we have discussed earlier, the different types of the EPS geoform density and their corresponding the initial tangent modulus, yield value and as well as compressive strength. So, now I will show you a relationship between the density of the EPS geoform and the compressive strain at a particular strain value. So, let us say it is a 10% strain or 5% strain. So, here I am just showing one example that what should be the relationship between density of the EPS geoform and the compressive strength of the EPS geoform material. You can see here, this is the compressive strength in kilopascal and this is the density of EPS geoform material. Okay. It may be 15 to 30 with the 4 defined types of the EPS geoform material, and this is shown as a compressive strength at a 10% strain. So, this is the relationship between the density of EPS geoform rho and the compressive strength of the EPS geoform at 10% strain. You can see you can obtain a straight line like this under different density. So, you can draw a correlationship between the compressive strength of the geoform sigma c with respect to the density of the EPS geoform. That means, sigma c will be equal to 5.799 rho minus 23.09, where this R square value is 0.998. So, this is for a particular strain value, 10% strain value. For example, if you know what will be the density of the EPS geoform material, so then you can directly determine that what will be the compressive strength of the geoform using those equations for a particular strain value. Similarly, you can draw a correlationship between the EPS geoform density and versus the compressive strength of the geoform and a particular strain, for example, 5% strain value. So, then you can have a correlationship between the compressive strength and the density of the geoform for a particular EPS geoform. So, if you know the density, then you can determine what should be the compressive strength of the EPS geoform material. Now, I am showing you a relationship between the density of the EPS geoform and the compressive strength at yield. We have shown for a particular strain value of 10%, you can also draw a correlation between the EPS geoform and the compressive strength. Here in slides shows that compressive strength versus density of EPS geoform material for a compressive strength at yield. So, you can draw a straight line for you can draw a straight line here for the different density. So, you can determine that compressive strength value of the EPS geoform material, that is sigma c is equal to 4.689 rho minus 15.01, for R square is 0.988. So, from this equation you can determine what will be the compressive strength of the EPS geoform material at yield. So, if you know the density, you can determine the sigma c with this equation directly. I will show this another slide, that is compressive strength result as per different test specimen. So, we have performed the compressive strength of the EPH geoform with different density. With the different type of the method of EPH geoform material. Suppose we have performed as per ASTM, American Society for Testing Material, we have performed the strength as per the IS, we have performed the test as per the DIN, and also we have performed the test as per the specification developed by IIT Bombay, and then we compare the result with the particularly with the ASTM with the proposed unconfined compressive strength of the EPH geoform material developed by IIT Bombay. From this slide I can show you that you can see this is density we have taken 15 kg per meter cube, 20 kg per meter cube, 22 kg per meter cube, 30 kg per meter cube. And this is 5% as per ASTM D162110. This is for 5% represent the compressive strength value of EPH geoform which calculated, and then 10% represent the compressive strength of the EPH geoform is calculated for a 5 and 10% of axial compressive stress specimen. So, this is IS 4671-1984, also calculated the compressive strength in terms of kilopascal at a strain of 5%. This is 55.75, 82.98, 102.07, 136.23, and for 10% this is 63.08, 92.56 for a density of 20 kg per meter cube, 112.07 for a density of 22 kg per meter cube, and 151.11 for a density of 30. So, this is the DIN specification to determine the compressive strength of the EPH geoform, that is as per 53421 in 1984. For 5%, for a density of 15 kg per meter cube, compressive strength is 56.89. For a density of 20 kg per meter cube, this compressive strength is 82.60. For a density of 22 kg per meter cube, this for 5% is 98.47. For a density of 30, this is 128.50. Similarly, for the 10% strain, for density of 15 is 60.72, for 20 density is 90.71, and for the 22 density is 108.31, and for 30 density is 144.03 kilopascal. And this is the proposed unconfined compressive test value. This is developed by IIT Bombay. For the 5% strain, for a density of 15 kg per meter cube of EPH geoform, this compressive strength value is 57.04. For a density of 20 kg per meter cube, this compressive strength is 85.33. For a density of 22 kg per meter cube, this compressive strength is 100.50, and for a density of 30 kg per meter cube, this compressive strength is 143.96. Similarly, for the 10% strain value, when the EPH geoform density is 15 is 62.92, and when it is 20, 93.03, and when it is 22, 106.16, and when the density of EPH geoform is 30 kg per meter cube, this compressive strength 150.07. So, you can see that different types of the compressive strength of the EPH geoform is given, and if you can compare with the ASTM and with the proposed unconfined compressive strength by IIT Bombay, you can see there is a Similarity 54.8, this is 57.0, this is 59.6 at 10%, this is 62.96. For 20 density 80.16 and this is 85.33, this is 88.4, this is 93.03, this is for 22 density 92.4, this is 100.50 and for 10% strain 108.2 to this 106.16, and for 30 density it is 128.20 and this is 143.96 and this is 142 for proposed, this is 150.07. So, you can see there is a lot of similarity between the ASTM and the proposed PUCT test. So, and from this table you have observed that density is increasing, the compressive strength value also increasing, and this IT proposed value of almost that nearer or little bit more than the ASTM value, and this is very simple test because everybody has a triaxial testing machine and one can perform the unconfined compressive strength of the EPS geoform material, and it is very easy to prepare the sample and also perform the test. So, this compressive strength of the geoform material is also interesting because one should know that what will be the compressive strength of the EPS geoform material. Next, we will discuss the tensile strength of the EPS geoform. So far we have discussed about the compressive strength of the EPS geoform, and now we will discuss what will be the tensile properties of the EPS geoform, and this is as per ASTM D162309. So, here the main objective of this test to determine the tensile strength property of the EPS geoform. The recommended the type A test specimen with this dimension is shown here, because there are different types of the tensile strength of the EPS geoform material. So, also equally that we have also developed certain kind of the tensile strength of the EPS geoform, where in our case you can prepare the sample easily and you can perform the test very easily with respect to the ASTM code specification. In case of the ASTM code specification, the preparation of the sample is very tricky and very difficult, and also it is a time consuming, and we have performed the test as per ASTM and we have also performed the test as per our proposed tensile strength of the EPS geoform and compare the result, and we find that is quite matching with the both the test. So, here that you can see that this is a kind of the tensile stress specimen of the EPS geoform, and the size here to here about 25 millimeter and here to here is 41.5 and here to here is 41.5 and this is 55.5 millimeter and this total is about 108 millimeter, and you can see here this is about 28.7, this ammeter is 28.7. So, this is the tensile strain test specimen of geoform, and this kind of the dumbbell shape of the EPS geoform material and the preparation of the dumbbell set of EPS geoform material is complex. So, in the right hand side I have shown that this is the different color, because for different density of the EPH geoform material, this is 15 kg per meter cube, this one 20 kg per meter cube, this is 22 kg per meter cube, and this is 30 kg per meter cube of the geoform material. So, I will show you that different types of the test of the EPH geoform and what kind of the failure of the EPH geoform may occur. So, here you can see that before the test, this is in the universal testing machine, and there is a clamp at the top and the bottom, and then you perform the tensile test of the EPH geoform material under different density. So, this is before, and you can see after the test for the defined density, and this how the sample fell. It fell almost at the middle of the here. You can say this is the failure, this is a kind of the failure you can observe from this test. Now, we know that how to perform the test of the tensile strength of the EPH geoform material, and what is the kind of the failure, and now how to calculate the tensile strength of the EPH geoform material. So, I will show you that tensile strength is calculated divided by breaking load by the original minimum cross section of the specimen. So, tensile stress, so let us say designated as sigma of T, okay, tensile stress. So, sigma of T can be written as F, this divided by pi into d square, this divided by 4. So, what is F? F is the tensile force applied on the specimen. So, what F is the tensile force applied to the specimen, and unit is kilonewton. And what is D? And D is minimum diameter of the test specimen. Okay, let us say that in terms of meter. So, you consider one of the density of the EPH geoform material, in which you want to determine what will be the tensile strength of the EPH geoform. Let us say that considering density of EPH geoform is 20 kg per meter cube. Let us say for a density of 20 kg per meter square cube. Then you have to determine what will be the tensile strength of the EPH geoform. So, as I said that tensile stress is equal to breaking load divided by cross sectional area. Cross sectional area of the sample. So, here breaking load, let us say 0.14. This divided by pi into cross sectional area, I have told 0.0287 this square, this divided by 4, because this is pi by 4 into d square and d is this. So, now you can calculate and can determine what will be the tensile stress of the EPS geofoam for a density of 20 kg per meter cube. So, this will give you 216.40 this kilopascal. So, this is the tensile stress of the EPS geofoam for a density of 20 kg per meter cube. So, you can determine that tensile strength of the geofoam, EPS geofoam material, because tensile strength also very important. You know, for every infrastructure there is a compressive stress and there will be the tensile stress. If there is a requirement for any tensile stress of the geofoam material, so you should know what tensile stress value you should adopt for a particular application and what should be the density of the EPS geofoam material. Now, to perform the test, what I am showing that what kind of the apparatus and accessory require. You require testing machine, you require gripping assembly and load cell and the extension indicator. So, here you can see the box and this is the jaw, and this kind of dumbbell shape of the preparation of the sample and the jaw and box is quite complex. So, this is a kind of the gripping arrangement or gripping assembly, and this is the geofoam material for ready for the tensile strength, and this is the before the tensile strength of the EPS geofoam material, and you see after you perform the tensile strength test on EPS geofoam material, and you can see there is a breaking of the EPS geofoam material here. It is almost at the middle of the sample. So, this is their indication that there is a failure of the EPS geofoam material. And testing procedure, you measure the cross sectional dimension and calculate the cross sectional area of the specimen. Place the specimen in the gripping assembly and mount the assembly in the testing machine. Determine the load at failure or break, and then you can calculate what will be the tensile strength of the EPS geofoam material. So, from this test, you can calculate, you can draw a correlation between the tensile strength and the deformation, or you can say this is the stress strain behavior of EPS geofoam for a particular density of 20 kg per meter cube. So, this is the tensile load in Newton and this is the deformation millimeter, and This is the strain curve of the EPS geoform of 20 kg per meter cube. So, for the particular deformation 4.7 millimeter, you can see the tensile load is 140 Newton. So, this material not only that give the compressive stress of the EPS geoform material, but also it provide us the tensile strength of the EPS geoform material. And for the defined strain value, you can also determine what will be the tensile strength of the EPS geoform material. Suppose here in this slide, we are taking density, we have taken that 15 kg per meter cube, 20 kg per meter cube, 22 kg per meter cube, 30 kg per meter cube. This is as per ASTM D162309. So, tensile strength for 15 kg per meter cube 154.89 kilopascal. For 20 density, the tensile strength is 216.40 kilopascal. For EPS density of 22 kg per meter cube, the tensile strength is 244.54. And for density of EPS 30 kg per meter cube, the tensile strength is 407.78. And here you can see that what will be the strain at failure. So, for this tensile strength value, the strain value is 2.56. For case of 20 EPS, and the strain value is 2.71 percentage, and for EPS density of 22 kg per meter cube, the strain at failure is 2.75 percentage. And for 30 EPS density, and this strain value is 2.82 percentage. This is the strain at failure. Here you can see for different density and different types of the failure pattern of the specimen in tension. So, you can have the idea that different types of the density and what will be the type of the failure pattern, and most of the cases the failure of the sample has fell at the middle of the sample. And also you find that tensile strength also is increasing with the increase of the density of the EPS geoform material. But one observation that most of the cases the strain value is almost to 2 to 3 percentage. The sample fell within the 2 to 10 percentage failure. So, the tensile strength of the EPS geoform is needed